Just imagine a computer so powerful it could solve problems we currently think are, well, impossible. There's one company that claims they're on the verge of building it, and in this explainer, we're going to dive deep into their roadmap to see if the reality can actually match the hype.
So let's start with this. This is the central, and you have to admit, incredibly audacious claim from a company called IonQ. In a field packed with tech giants and brilliant startups, saying you're the leader in every metric that matters, that's not just confidence. That's basically a declaration of war. So what's behind it?
So who is this company, IonQ, making such a bold claim? We are about to unpack their entire strategy, and we're going to use their own roadmap, their own data as our guide to see what this leadership is really built on.
Okay, a claim that big, it absolutely needs a rock-solid foundation. IonQ starts by pointing to the numbers. The hard data they believe proves their dominance in the market. Let's take a look.
First up, the money. They call this a fortress balance sheet. And yeah, with $3.5 billion in cash and investments, you can see why. This isn't just about funding. This is a war chest. It's designed to let them outspend and out-innovate the competition for years to come.
Next up, their defenses. We're talking technology here. With over 1,100 patents, they're building this massive intellectual property moat around their work. What that really means is it makes it incredibly difficult for anyone else to just come along and copy their unique approach to quantum computing.
And here it is, the engine for all their future growth. They are pouring over $200 million every single year into research and development, and that number is only going up. This is a relentless, non-stop investment in staying on the absolute cutting edge.
So what does this all add up to? You know, it's not just one thing. They're combining this immense financial power with crucial government partnerships. We're talking agencies like DARPA, and a team of over 1,000 experts. And get this, they're the first pure-play quantum company guiding to triple-digit revenue, which is a huge signal that this is moving from the lab to the real world.
So, with that powerful foundation in place, let's turn to the technology itself. I mean, how are they translating all that money and brainpower into actual hardware? Because this is where their claims about the future get truly mind-bending.
Just look at this timeline. It shows their incredible acceleration. They went from Harmony in 2019 to Aria in 2021, Forte in 2023, and Tempo is slated for 2025. Each machine is a huge generational leap, and they're not stopping. They're already planning for systems with millions of qubits. The pace of innovation here is just staggering.
And you can literally see the evolution right here on this slide. We're moving from something that looks like an early lab experiment, all wires and racks, towards this sleek, integrated hardware that looks ready for an enterprise data center. This isn't just a science project anymore, it's becoming a product. Okay, now this slide is where things get almost unbelievable. They are claiming their 2025 Tempo system will have 36 quadrillion times more computational space. What does that even mean? Well, think of it this way. If a regular computer can explore a maze one path at a time, a quantum computer can explore all the paths at once. Computational space is just a measure of how many paths it can explore simultaneously. And 36 quadrillion, that number is so vast, it's a completely different league of computing.
But so what? What can you actually do with 36 quadrillion times more computational power? This is where we get to the real-world payoff.
For starters, think about medicine. Designing a new drug means simulating how these incredibly complex molecules interact. Our best computers today can only really approximate this, but with this kind of quantum power, we could model those interactions perfectly, potentially discovering new cures for diseases in a fraction of the time. Or, hey, what about our energy crisis? A quantum computer could simulate brand new materials for hyper-efficient batteries, or maybe design catalysts that literally pull carbon right out of the atmosphere. It could also optimize our entire power grid in real time to prevent blackouts and save massive amounts of energy. These aren't small fixes. These are planet-scale problems.
In the world of finance, where trillions of dollars are on the line, this kind of power would be a total game changer. Imagine being able to model and rebalance a massive investment portfolio in real time, perfectly managing risk and spotting opportunities that are completely invisible to today's fastest supercomputers.
And of course, there's AI. Training the most advanced AI models takes an absolutely enormous amount of computational power. Quantum computing could unlock a whole new generation of AI, allowing robots, for instance, to learn and adapt to complex, unpredictable environments in ways they just can't today.
And look, this isn't just some promise for the future. IonQ is already publishing results that they say prove their advantage. They're demonstrating a 656 times faster solution compared to the best from AWS on a specific problem, and have already created the largest battery chemistry model ever on a quantum computer. These are tangible benchmarks showing the quantum advantage is already here.
So finally, let's zoom out to their ultimate vision, because this extends far beyond just building faster computers.
See, their ultimate vision isn't just to build faster computers, it's to create an entire quantum ecosystem. They're talking about a quantum internet for totally secure communication, unbreakable cybersecurity, and ultra-precise sensors. They're even working to extend this network into space. This is about making quantum a fundamental layer of our global infrastructure.
So this brings us right back to the beginning. IonQ's roadmap is incredibly ambitious, promising a future powered by quantum. But the real question is for us. As this technology moves from theory to reality, it's worth thinking about. If you had this kind of unimaginable power right at your fingertips, what's the one problem you would solve first?